So good morning, students. See, we have covered most of the concepts of just a minute. We have covered almost all the concepts of this oscillations. Just small things. Seconds pendulum, you find this term. Seconds pendulum. Okay. Seconds pendulum. If you find this term, seconds pendulum means the time period of that particular pendulum is 2 seconds. Remember this. That's it. So here, so suppose you are taking Earth. So T is equal to 2 pi into root over L by G. So T is equal to 2 pi root over L divided by 10. Okay. So this is 1 by 10 is equal to root over L by 10, or L is equal to 10 divided by pi square. This much will be the length of that seconds pendulum on Earth. So if you take it somewhere else, see, this time period is dependent upon L and G. Suppose you go to moon, the G value drops. So similarly, the L value also has to drop proportionately, so that the time period should be 2 seconds. Okay. So seconds pendulum, in any question, if you see, the only meaning of that is the time period is 2 seconds. Okay. So now let us discuss one more aspect. See, in this universe, every particle or a body has its own vibration, its own natural frequency. Suppose even if you keep, now let us say this is table and I keep a block here. To our direct eyes, we may not be seeing any vibration in this, but this object is basically vibrating. Okay, it will have some frequency. Now let us say you give some disturbance to this body. What will happen? This will start vibrating. Okay, but after some time what will happen? Suppose you tap a table, the table will vibrate more, then after some time it will reduce. So one type of, we have seen one type of vibration or oscillation was this type of we have seen. What is this? Harmonic. It will go on till eternity, till infinity. We assume that it will be like this only. Let us say you take a pendulum. Okay. You give an oscillation to the pendulum. The pendulum will oscillate like this. In between, what is there? Air is there. Now, if let us say there was no air, see, this air is giving some resistance, isn't it? So it is oscillating. If the air was not there, it will keep on oscillating like this till ever. Like this. Okay? Amplitude will rise, amplitude will fall, amplitude will rise, fall, like that. But in reality, there is some air. So air is offering some resistance. So what is happening? After some time, this will gradually die down and finally it will come to rest. Okay? So this type of oscillations which we see in reality are called damped oscillations. Damped oscillations. Damping is a kind of a friction only. Okay? So these oscillations are dying down. These oscillations are dying down with respect to time. Some air is there, air resistance is there, because of which it is dying down. So this type of oscillation is damped oscillation. This is undamped, ideal situation. Okay. So understood the basic difference between these two? So damped oscillations, what is happening to the displacement? Displacement, let us say this x-axis is time and the y-axis is displacement. Delta. So the displacement is dying down after some time. So that is damped oscillation. Okay. Now when you have given this some force, some disturbance, some vibration to this body, what will happen? When we are giving this vibration, there can be a situation that this has got its own natural frequency. I told you that every object in the universe is vibrating. Okay, however small it is vibrating. So this object which is kept on the table has its own natural frequency measured in hertz. It can be very small. It can be 0.001 hertz, let us say. However small it is there. Now you gave some vibration from outside. It is external, so that is called forced vibration. Okay? You gave vibration from outside, isn't it? Naturally, the object was simply sitting over there. You gave vibration from outside. What type of vibration is that? It is forced vibration. And this is the natural frequency. It has its own natural frequency. Now, this forced vibration, how it can be given? Just once you give it and leave it. You give it once and leave it. Or you keep on giving it. You keep on giving it after regular intervals of time. जैसे कोई टेबल पे मैंने हाथ मारा, फिर 2 सेकंड बाद फिर से मारा, फिर 4 सेकंड बाद, फिर 6 सेकंड, ऐसा भी कर सकते हैं, या एक बार टैप करके छोड़ दी. I tapped this object and left. Now, when you are giving some forced vibration, it will have its own frequency. And let us say the frequency of the disturbance you gave and the frequency of this block are matching. If the frequency, because of force vibration, when you are giving some disturbance, it will have its own frequency. That is forced frequency. So when forced frequency by some means, let us say, becomes equal to natural frequency, then resonance is developed. So forced frequency becoming, यहाँ पे 20 हर्ट्ज दिया, इसका भी 20 हर्ट्ज है मान लो, दोनों मैच हो गए, तो क्या होगा? Resonance will develop. Like previously also we have discussed, maybe in class 11, one of the session I discussed, that some time back what happened, the soldiers were march fasting on a bridge. The bridge has its own frequency, some natural frequency. Unfortunately happened so way that these soldiers who were march fasting on the bridge, their frequency matched with the bridge. You know what happened to the bridge? The bridge actually collapsed. So because of resonance, what actually happens is, this amplitude, what we measure, this amplitude shoots up. And what is amplitude? It's a measure of displacement. So the parameters which are related to the displacement also shoot up, thereby leading to some kind of a failure of that object, like in that bridge. Okay? So this resonance is a phenomena which is observed in oscillations when forced frequency becomes equal to natural frequency. So this is one point you should know. And these terms, undamped frequency, undamped oscillations and damped oscillations. Damped oscillations because of some air resistance. This is reality. Okay. कोई भी झूले को हम लोग ऐसा झूला करके छोड़ देंगे, तो after some time it will come down to rest. So this is how it happens. Okay. So this much, some terms you should definitely understand. Okay. So sometimes questions are asked like this. The expression for velocity is given v square is equal to 8 dx minus x square minus 12v square. Okay. And you have to find in this question what is amplitude, what is maximum velocity, what is time period. So this type of questions come. So how can I please? So here we will use our calculus knowledge. So differentiating both sides. Differentiating both sides with respect to time. What do you get? So this becomes 2v into v square into 2v into dv by dt is equal to 2v into dv by dt. So this is, see here b is a constant, okay. So 8b into dx by dt minus 2x minus 12b square. ये तो कांस्टेंट टर्म है, ये तो जीरो हो जाएगा. Did I note the question correctly? Yeah. It is 2x minus 2x into dx by dt. Since b is a constant, it will be 0. Okay. So we got here 2v. What is dv by dt? It is acceleration. And this is how much? 8v into dx by dt. It is v. And 2x dx by dt is again v. Okay. One v is common everywhere. You can write 2a is equal to 8b minus 2x, or a is equal to 4b minus x. Okay. What did I do? I differentiated both sides with respect to time, and here I am using the calculus knowledge to calculate the maximum velocity, acceleration, all these things. What is this a? This is the acceleration. Okay. Now tell me, when acceleration is equal to 0, you get what? What can you say about the velocity? Look at this pendulum. Now this is the main position. Let us say this is the extreme position. Extreme position. At extreme position, what is maximum? A is maximum, V is minimum. Here, V is maximum, A is minimum, which is 0. And here again A is maximum, where V is minimum. Right? So when A is equal to 0, V is maximum. Right? So if I put A is equal to 0, what am I getting? I am getting x is equal to, if I put A is equal to 0, I am getting x is equal to 4b. X is equal to 4b is the location where you are going to get the maximum acceleration. Now, so what do we have to find? We have to find the time period, we have to find the maximum velocity. So maximum velocity, how to get the value here? X is equal to 4b. Okay. Now acceleration is equal to 4b minus x. We have got an expression. So okay. If you see these two positions are extreme positions. This was our original equation. At this extreme position, there are two positions. What is happening? Your velocity is minimum. What can be minimum velocity? It can be 0. So if I equate this to 0, what will I get? 8bx minus x square minus 12b square is equal to 0. If I put, I am taking b is equal to 0. What is the unknown here? Here the unknown is x. So this is a quadratic in x. I will get two locations for x. I will get two locations for x where the velocity is minimum. So let us solve it. So this is x square minus 8bx plus 12b square is equal to 0. See, one way of doing it is like this: when acceleration is equal to 0, x is equal to 4b, you got one location. Now let us solve this. So can we factorize it? 6 2s are yeah. So x square minus 6bx minus 2bx plus 12b square is equal to 0. So take x common, x minus 6b, and if you take here minus 2b common, you get x minus 6b, isn't it? So you are getting x minus 2b into x minus 6b is equal to 0. So you are getting basically two positions of x where the velocity is becoming 0, 2b and 6b. So what is the amplitude? The amplitude will be the difference of these two. Okay? So it is like this: x is equal to 2b, x is equal to 6b. So where it is oscillating? It is oscillating in between only, no? Okay? So the amplitude will be equal to 6b minus 2b 4b. Okay? So one we have got it. Now maximum velocity. So maximum velocity, where we are going to get? We are going to get at x is equal to 4b. This we have seen here. So we can substitute that. Okay, just write on this. I'm going to remove it. So here we have seen that we are getting v maximum, isn't it? For a is equal to 0. X is equal to 4b is correct, no? 2ba is equal to this. So 2a is equal to 8b minus 2x, 4b minus x, right? So x is equal to 4b. So if you put x is equal to 4b here, you are going to get the maximum value of the velocity. So just calculate that. V square is equal to 8b into 4b. How much? 32b square minus x square, 4b square. So it is 16b square minus 12b square. Right? What I have done is, basically I differentiated this equation. I got an expression for acceleration. I just cancelled out velocity, was common both sides, so I just cancelled it. Then I got a general expression for this. For different values of x, we get different acceleration. But you know that when acceleration is 0, velocity is maximum. Velocity becomes maximum, right? So acceleration is what basically dv by dt. No? When dv by dt becomes 0, velocity will be either maximum or minimum. It hits the maximum or the minimum when dv by dt becomes equal to 0. It's like this, some curve. So here what is happening? Here the slope is becoming 0, no? It is parallel to x-axis. So at this point, if this dv by dt, v versus t graph, what is dv by dt giving? Giving me slope. So if you are, it is keep on increasing. At some point, dv by dt become equal to 0. Then it means it has attained the maximum acceleration. So just calculate this now. So 32 minus 16 is 16. 16 minus 12. How much? 16 minus 12 is 4. 4b square. So you can write this as v maximum, right? Because you know that at x is equal to 4b, you are going to get the maximum value of the speed. So v is equal to 2b units. This is v maximum. V maximum is equal to 2b units. So we have calculated v. We have calculated amplitude. Amplitude was how much? 6b minus 2b is 4b, right? Amplitude is 6b minus 4b. Is it 6b minus 4b? See, This is corresponding to x is equal to 2b and this is corresponding to x is equal to 6b. So where is the mean position actually? So it is one extreme, it is another extreme. What will be amplitude? Amplitude will be half of this. Isn't it? Amplitude will be how much? It will be 6b minus 2b by 2. सही बोल रहा हूँ? देखो ये एक एक्सट्रीम पोजीशन है, ये दूसरा एक्सट्रीम पोजीशन है. मान लो कि ये और ये सेम है, तो मेरा एम्पलीट्यूड कितना होगा? अगर यहां से यहां तक मुझे डिस्टेंस पता है, उसका डिवाइड बाय 2 करेंगे तो मुझे एम्पलीट्यूड मिलेगा. एम्पलीट्यूड इज दिस, एम्पलीट्यूड इज दिस, यू नो. तो आई हैव टू टेक व्हाट? At x is equal to 2b, x is equal to 6b, the particle is oscillating between this point to this point. What will be the amplitude? It will be 6b minus 2b divided by 2. So your answer should be 2b. Okay? Answer should be 2b. So you have to find the time period. So Vmax is equal to a omega. So Vmax is 2b is equal to a is 2b, omega is equal to 1. Am I saying the right thing? Extreme to extreme, no? X is equal to 2b. What are when we solve this equation equal to 0 at two locations, we are getting v is equal to 0. V is equal to 0 कहाँ है? यहाँ है, यहाँ है. Okay. So from this location to this location, you know the distance. So the particle is oscillating between these two. So half the distance should be the half the distance. जैसे circular motion में मान. ठीक है? So this is amplitude and this is also amplitude. Okay. So here to here you know the distance. So what is amplitude? This distance divided. If this distance is s, I told you, your amplitude will be s by 2. So it will be s by 2. It will be 2b. Amplitude should be 2b. So from here you are getting omega is equal to 1. So omega is equal to what? 2 pi by t. So t is equal to 2 pi. Small correction you have to make. 6b minus 2b by 2 it should be. Okay? And not 6b minus 2b is not amplitude. You have to take the half. Remember this what I told in the previous classes. You have to calculate s divided by 2. Okay? See, in case of springs, suppose you are given two springs and they ask you some 4 kg is given and they ask you to find out the time period of this. How you are going to do this? Suppose this is given as 2 Newton per meter and this is 4 Newton per meter. Okay. See, the time period expression was t is equal to 2 pi into root over n divided by k. But what is this k? This k is k effective. So that means you need to replace these two springs with a single spring. In what way these two are connected? These two are connected in series. So this diagram is equal to saying that some single spring is there whose k effective we need to find first. Okay. So k effective कैसे आ जाएगा? When they are in series, it is k1 k2 by k1 plus k2. So it is 2 into 4 divided by 2 plus 4. So 8 divided by 6. It is 4 divided by 3. Okay, mass is given. So the time period will be equal to 2 pi into root m. M is 4. 4 divided by 4 by 3. So it is 2 pi into root 3. This is your answer. Now in the same example, let us say, to confuse you, just note it down. Suppose they ये मास यहाँ हटा करके यहाँ लगाएंगे. Some kind of situation, ऐसा कुछ कर दिया. Then are these two in series? No, they are parallel. Then what will your k value become? K value will become 2 plus 4, 6. 2 plus 4, it will become 6 Newton per meter. And this value will change. Okay? So be very careful where the mass is put. तो इसके पहले वाला that was series, but this is not series. This is parallel. Okay? So note down this point. And let us see. I think most of the points I have discussed. Now you have to solve and come to me with some doubts only. I am seeing if any other. And this point, I don't know whether I told you or not. See, acceleration was proportional to minus displacement, or acceleration is equal to minus omega square y is what we have written, isn't it? Now this is the expression, right? Now, what is the differential form? How do you write A? You write A as d square y by dt square, isn't it? You write d square y by dt square. So can we write this expression as d square y by dt square plus omega square y is equal to 0. Now this is the differential form of the simple harmonic motion. This is the differential form of this is the standard equation for simple harmonic motion in the differential format. So suppose some y function is given to you, y is given as some 2 sine omega t plus phi etc. Okay. So here y means it is a SHM motion, and this is the format. You should be able to reduce this whatever that is given into this format. So then also you say that it is a simple harmonic motion. Okay. So remember this differential format. Here how I have done. Okay. This is basically what we have done in the previous classes only. Just we have replaced acceleration by acceleration into differential format. So often it is also useful. So energy principles I have discussed, how the energy role plays there in the simple harmonic motions. Law of conservation of energy you can apply here also, and that's it from me. I think I would suggest you that you start solving numericals from standard books, and please post me. I will reply to your queries. Okay then. Any other thing? If by chance I have missed, please bring it to my notice. I have mostly covered all the parts. Okay. So with this, I will meet you in the next class. Okay. With a new topic. We have discussed that we are going to discuss this modern physics. So now you have to solve numericals and ask me notes. Okay then. Take care. Bye bye.